Okay, good morning. On behalf of Vionice, I am Markus Melander, entrepreneur, co-founder of the Vionice, and very enthusiastic on computer vision. We've been sitting now an hour, so let's make a little rehearsal here. Please set your tablets or laptops to the table. Please stand up. Stretch a bit. It makes good for you. Okay. Can you hear me? Okay, good. Please turn to your person next to you and focus on a little bit what kind of person he is, okay? And then focus on the items that he is having in front of him on the table. There, it might be empty or there is something. Okay, please sit down. And now, if I ask you, what color was the shirt of the person that you was looking at? Most of you don't remember. And this is the reason, one of the reasons why there is a Vionice. We are making technology with computer vision to make the road and rail or whatever kind of field data collection as easy as possible with computer vision. Couple of illustrations, like we are building a system to make, for example, your fleet to be smart. We are cooperating in these methods now with UPM, Forest and Stora Enso at the moment, for example. The idea that if we want to make our fleet smart, we need to make them to see. The concept that we are building is very simple, basically. At the moment, we are using mobile phones only to stream the HD quality video from the fleets or from other handheld devices to the cloud and do the computer vision extraction there. And the reason exactly is what I illustrated you here in the beginning. The background for our innovation comes from the Finnish Transportation Agency where I used to work, and I was responsible to carry out the development of the asset management system and processes inside the Finnish Transportation Agency. And I noticed that, okay, I have a roughly 10 million euro budget. We can make a really good databases, user interfaces to manage the data, but what good it is for if there is no processes to provide the data in modern means. So now our vision is that we can bring computer vision to whatever kind of vehicle, and it will help to collect the information and verify everything, because we also transfer the visual data from it. And these kind of processes that you can see here are basically our main focus. Our customer base at the moment are municipalities, road agencies, contractors and consultants who are working for them. But then on the other hand, we are having organizations doing pilots with us and R&D joint operation, as I mentioned you, forest industry, big players, postal service, many transportation service providers, and so on. But the whole idea is in little details and make it as easy as possible to collect the field data. The concept simply is here. So by using or choosing the mobile phone to be a platform, the cameras are so good that we can just use these items in basically in every use cases. Of course, we can have a fixed camera, but in many cases the data is not so expensive that we can put more expensive hardware in that. We are proceeding now with VR track and one German partner in trains to have more expensive cameras and on-site calculation also. So bringing the computer vision inside the vehicle. But mainly our architecture and the main service that we are providing is a cloud-based software as service system. So I'm talking now about a lot about video, and about computer vision is part of it. What we have learned now, we have founded in 2014 in December, so it's going to soon be a 3 years travel that we have been doing. There is now 14 people in our team, 8 of them are regular and the rest are part-timers. We started only by doing a computer vision service, and we thought, okay, hey, this is the good hit and we can make a good business out of it. And we noticed that, okay, it's a little bit like we are too early in the time. They are not interested. So we ended up to the situation that actually the content management for all the visual material in the field is more valued at the moment. And it's based in the system now that, okay, you have all this visual material and then you can make an inquiry. Where is potholes on my road? Where are all the parking signs in my city network? What is the condition of the zebra crossings? And then the computer vision algorithms finds out you the answer and give it to the maps or desired kind of API format. In our system, these are like the 3 statements that we stand on. So in the future, it's very clear that the computer vision and machine learning is going to take a lot of the work that the man is doing now. And we took quite an interesting challenge to try to provide the computer vision to the field, which is quite old-fashioned in engineer work in public works. But it's been interesting and we are proceeding well. Because it's so easy already now with the 4G network to provide not real-time detection in low cost, but rather up-to-date information, simply because you can use the fleets, and it's rather not inexpensive also to provide the equipments to the cars to collect the information. And then the up-to-dateness is more and more important already now, but when we come to the future, even more. There are like 2 big drivers. The one is, of course, when we are talking about the traffic, is that the traffic is changing very rapidly at the moment. Let's not go into the details. But on the other hand, the other big driver is that we humans are like that. When something is possible, we are tended to go forward into that. So we are like, okay, the processes are capable to provide up-to-date information. Okay, I want to have it. Then from technical perspective, what we do, so we use the fleets to stream the data to the servers. Huge amount of data. It's like 85,000 hours of video was the last figure that I remember from the summer that was coming into our servers in 1 week. Information for the users we use, it's a spatial format with a 3D point cloud. So we basically make a photogrammetrical 3D point cloud of everything, and then we use that to map the information to the right locations. And then the computer vision algorithms are used to extract the information, classify it, and provide the desired information to the users. I have here a short video. I won't show it whole, but a couple of technical details, so how it works. So I just want to point. Okay, there's music also. So here you can see now the detector and classifier here. Our aim was to detect the plants and map the green spaces in a joint operation with Destia and Liikennevirasto. So this is like the end result from the computer vision engine. To map it, okay, I can't put it go forward, so I try still. Now it seems that it's not possible. Okay, then leave it because I'm going to go over time. So what I would like to show you is like, because in the video there, but the next step is that you make a 3D point cloud, but it's just a little bit too long video. Yeah, I have here 5 minutes time. So that's the important part, to know and identify the objects. And then there is a segmentation that you can understand basically everything from the videos. The end results that we are providing is here. So what we, for example, in this illustration we are providing, so when the fleets are driving around the network, we are, in this case, providing the weather information identified from the visual images. The same concept as here is now we can see, okay, there is snow on the road. Here the other one is that it's wet and it's raining. The confidence levels are very important for the automated detection and to provide the information to be used better in the future systems or in the other systems that are using the data. We are using the same algorithms now to detect the quality of the road, defects of the road, traffic sign inventories, and so on. Here is another illustration about the sign objects, or let's say that the point object identification. So here you can see this is a visualization only that how the detector is working and the classifier is classifying the objects. And then you get basically the end result, how the detection is done, and all the information is on the maps. And this can be other objects also than only like traffic related. This is another interesting perspective to the low-cost system to make something interesting. From the frontal view video from the truck, we generate an orthophoto projection and we make the lowest level map layer of it. So basically what you get, I can provide you now, just go in your car, put our application on your screen, and you will get basically up to date, not in real time because it takes a bit to stream the data and the algorithms to run, but you will have a map layer that you can zoom in and get this kind of image of the road. And this example here is about road marking condition analysis that we are at the moment doing jointly in an RT program with Vegvesen, the Norwegian Road Administration. Okay, the last minutes, this is now maybe a commercial part of this. Our system is not only to record the data from the cars. We started in the way, but we noticed that the customers are doing it also with handheld. So this is maybe something that you might be interested to provide to your field agencies or somehow. We have been doing cooperation, for example, the Finnish Environmental Agency. They've been collecting some bad vegetarian areas and so on, doing mapping with the application, getting the information easily to shared inside the organizations or to the other shareholders. I want to use the last minutes to show you something in line. Am I doing something wrong? Or sorry for this. But this is how it looks like. So basically the situation we have a public reference that we can use now. So one fleet is driving here around in the eastern Finland. We can get now the weather reports, and then and this is how simple it is to access now. We are not seeing it. You are not seeing it. Sorry. Can I do something for it? Sorry. So there. This is not, I didn't choose the topical data, but all the data is scattered inside the system. So this is now from the 19th. But basically there is now, in this reference project, there is 36 trucks driving around to Finland and collecting this data. If someone is asking about the data security, is that we have an anonymization algorithm that is removing all this kind of phenomena like register plates and faces. Thank you. I think now it's time for questions.
Thank you very much. So who start the first question?
Okay, can you comment somehow the real business and how to monetize this and who will pay and so on?
We were just celebrating our 600 customer account this Tuesday, And how the monetization is going here, that we are providing this as a software as a service-based system. There's a monthly fee per organization for using this as a data management. There's a user-based fee per each user who is using the data to stream it or look it, getting information out of the system or putting it into the system. This is something that you negotiate with each of the customer. Our biggest individual customer is having more than 300 users inside their own organization. And then the automated information production, which is done from the customer's own material, then those are based according to the value of the data. We are very aware that there is some information is very valuable and something is not. But the system, how we have built it, is a very low-cost calculation power, and it's like we can price point it according to the customer's desire for the data. What we are basically fighting against, or where is the competitive edge, is that, okay, in countries like Africa or India, there is very low-cost work labor. They can collect data very in low cost. But then they have a problem that it's not very reliable. Okay, but then in the Western countries, the specialist engineers who are collecting, for example, road or rail information by walking, for example, in rails, they do a lot of walking inspections. There is a very, let's say that there's a huge potential for savings which are already in real. But this is the concept, how is it going?
Timo Tahvanainen from Joensuu Science Park. So you are collecting mainly visual information, visual videos of the road. Can you also detect, for example, get information about the structure of the road, others than need for cleaning or locating these potholes?
You mean the structure is that what shape is or the angle, for example, on this kind of issues, or what do you mean?
Or how much it can bear?
Very complicated question in many ways. Basically what we are doing is that we are comparing the human eye and its analysis about the condition of the road. For example, then now the gravelly roads, so the sand and the forest roads, condition analysis is done with the, it's like the system, the AI has been now taught with roughly 60,000 images of the bad conditions of the road. And then this is basically a decision support system. So it's providing, for example, information that in these 70 areas there is something problem. Please check. Somebody goes and check it. Okay, makes decision. Let's fix these 5. So I don't know, does this answer well, but you can't like measure anything. You can only make the estimation as the human would done by looking to the road.
Yeah. So do you already have a way to how to get this data collection to, for example, for forest trucks, which are operating mainly in lower?
Yeah, as I mentioned, maybe I didn't emphasize it strong enough, but we are having now this kind of joint R&D project under the Metsäteho, and we are having all the relevant organizations in Finland as a participants. And the question and the discussion actually in this program or this project is that should we make or shouldn't we make this kind of joint information gathering platform? It's called in Finnish open metsätietieto, avoin metsätietieto, so that it will help everybody to plan better their routes for the maintenance, to get better information faster, and so on. So there is like it's easy route. Just come and discuss me and let's make a deal. It's already on the markets.
But you are now kind of piloting. When is the time that you are making?
When the customer makes the decision. So we are already having like customers doing. For example, in UK, similar kind of is already in operational.
Well, my question was that do you have an idea when your pilot is ready and when the forest industry and Metsäteho are ready to make the decision how to go forward?
I don't really know. I have been meeting now colleagues in different these organizations, but let's say that it's not clear yet that where's the value. It's like, let's say that because it's a bit complicated. Somebody owns the road. Okay, they have very straightforward understanding on that. But then the discussion between, okay, what is the part of the FTA, what is part of the private road owners, and so on. So who is paying and for what? It's not so clear yet. This is let's say that is frankly a bit problem in our concept. So it's very easy to provide the system for someone who's owning the road and maintaining it. That's simple. But if we really want to make this kind of platform, so it's even though this is not expensive system. So still it's like a bit challenging. But I think that it seems very promising, but I don't know yet.